Today's lesson is from Unit 4. This is Section 4.7, Arithmetic Sequences. This lesson will teach me to define and give examples of a sequence, determine if a sequence is arithmetic, and find the nth term of a sequence using a recursive process. Arithmetic sequences. The definition of a sequence is kind of twofold. There is a simple definition, and there's a mathematical definition. The simple definition is that a sequence is just an ordered list of numbers. So here's my example: 3, 5, 7, 9, ... It's a list of odd numbers. The mathematical definition of a sequence is that it is a function. Remember, a function has one input, one output, whose inputs are the position and whose outputs are the terms of the sequence. Let me give you one more definition. I'll go back and explain the mathematical one. The terms of the sequence are just each number in a sequence. So the 3 is a term, the 5 is a term, the 7 is a term, the 9 is the term. Because those are terms, those are essentially our outputs. The inputs are the position. So the number 3 is the first number. 5 is the second number. 7 is the third number. And 9 is my fourth number. So all of these, if you want to think of them as x's, are the positions. And your y's, your outputs, are the actual terms. Couple more definitions. There are different kinds of sequences. The one that we're working with particularly here is called an arithmetic sequence. Think about arithmetic when you were in grade school, adding, subtracting, those types of operations. So an arithmetic sequence is a sequence where the difference between each term is constant. Think about your linear functions where you're adding the same number down the y column each time. That's really an arithmetic sequence. When it talks about common, where the difference is the same, we refer to that as the common difference. That's the number that's being added or subtracted every time between the terms. Some non-math examples of a sequence, just so you can see what the mathematical definition is. Since a sequence is a function, we can use function notation. So here's a sequence where f of 1 is January, f of 2 is February. What sequence is this really dealing with? We're talking about the months. The input, the number going in, is the position. January is the first month, February is the second month. So what is f of 10? Well, it's really asking you what is the 10th month, which is October. There's a non-mathematical definition of sequence or example. Here's another one over here in blue. It says f of 1 is A, f of 2 is B, f of 3 is C. What is the sequence? It's the alphabet, where the first number or the first letter is A, the second letter is B, the third letter is C. So what's f of 10? Number 2, it says tell whether the sequence is arithmetic. A sequence that's arithmetic is either going to add or subtract the same number each time. That same number that's being added or subtracted is referred to as the common difference. So let's go ahead and look at the first example. 8, 15, 22, and 29. Add 7, add 7, add 7. So is this arithmetic? Yes. And the common difference is the number that's being added or subtracted each time. I'm going to abbreviate CD for common difference, equals 7. Lastly, it says list the next two terms. Well, if I continue to add 7, I will get 36 and 45. Letter B. It looks like 7 to 9, we're adding 2. But 9 to 10, we're only adding 1. and 10 to 12 we're adding 2 again. So we're not adding or subtracting by the same thing each time, so it's not arithmetic. And then the last one. From 10 to 4, we're subtracting 6. From 4 down to -2, down 6 more, down 6 more. So it is arithmetic. The common difference is that number that you're subtracting each time. So the next 2 terms, so -8 minus 6 is going to give me a -14, and minus 6 more is going to give me a -20. There's 2 different ways we can deal with sequences. We can deal with them recursively and explicitly. Today we're going to deal with the recursive process. The recursive process is a process that relates each term of a sequence after the first to the ones before it. Think about that it's recurring over and over again. When you have the recursive process,
Good morning, Mr. Thomas.
sorry about that. When you use the recursive process, you're basically just adding the same number over and over again. You need to recognize the common difference, and you need the previous term. So if you want the 6th term, you actually need the 5th term. If you want the 200th term, you're going to need the 199th term before it. So number 4 says, write a recursive formula, which we're not really going to write a formula. We're just going to find the indicated value. So let's look at this. We have 70, 77, 84, 91. So it looks to me like the common difference is a positive 7. 70 is our first term, second term, third, fourth. Well, I want the 8th term. So the 5th term, 6th term, 7th term, and the 8th term. You're going to have to add 7 each time, so that's recurring. You're adding 7 over and over again. So 91 added 7 is 98. Add 7, you're at 105. Add 7, you're at 112. Add 7 more, you're at 119. Go ahead and try letter B, and we will go over it. Actually, I'll go ahead and do it with you. There's no sense in going over it tomorrow. Let's check. Is it arithmetic? We are adding 6, adding 6, adding 6. So there's my common difference. And I want the 9th term. Well, the 3 was the first, second, third, fourth. 5, 6, 7, 8, 9. So we have to turn around and add 6 to the term before it until we get to the 9th term. So 27, 33, 39, 45, and 51. So if you wanted function notation, f of 9 ends up equaling 51. And over here, f of 8 ends up equaling 119. This process is not very efficient, which is why there's going to be a second one that we will work with tomorrow. Your homework tonight is a worksheet, and you are doing, it looks like, problems 1 through 11 from the worksheet. Thank you. Have a good afternoon.